Welcome to part 18, in our tutorial series on how to develop a CONTRA Like game, with free visual game engine Gdevelop. In this video, we're going to fix some bugs in the fall through the platform system, and implement the water walking. We are also going to implement the fire down mechanic that was still missing due to missing animations. We will also explain how we have generated the animation and the workflow that we have followed. Finally, we will fix some more bugs associated with the bullets layers. So, without losing more time, let's jump into the action. But, before beginning, let's refresh some of the basics of the game. As you can see, when falling into the water, the player is giving the impression to be submerged under the water. And when shooting laid down, the animation changes to a lead down pose where the firing point goes down to almost the ground level. This allows the player to kill enemies that are crouched or hidden behind bushes. Let's start with the fall to the water and water walking. Actually, if we fall from a platform, we don't see anything, as the player goes under the platforms and once reaching the water, falls into infinity, as we have not limited the bottom of our level. Let's address those two things first. In the main game events sheets, let's open the player init state. After the spawn of the player sprite, add a new action associated with the player sprite. In the search box, type Z order and select the corresponding option. Then in the action box, type set to, and in the value, type physics player Z order. This will guarantee that our sprite will always be on the same depth of the physics player object. Let's run the game. And now, the player stays always in front of the level tilemap. Let's avoid it to fall through the bottom of the level. We need to put an obstacle as we have done to limit the left and right level bounds. Let's create a new object sprite and name it water limit. Click on Add Animation and then on Edit with Piskel. In Piskel, select the blue color, and with a paint bucket fill in the canvas. Name it Water Limit, save and go back to Gdevelop. In the top bar, click on Behaviors and add the platform behavior to the sprite. Click Apply to exit. Resize the water limit to be as wide as the overall level and place it at the water level. In our case, we are setting to be more or less around the feet of the character player. If you want more depth, then lower down the position where you will be placing the object. Once done, let's go to the game main events sheet, to the top, where we can find the on the beginning of the scene event. Let's add an action associated with the water limit and with the hide function. If you want, you can just copy the previous hide action and customize it for the water limit. Let's run the game and let's fall from the platform. We fall into the water, and now we can walk on it. But we have two problems. Our gun is not there, and it doesn't feel that we are walking on the water. We need to add some effects to make it more believable. For the gun, it is the same problem as for the player sprite. In the player init event sheet, let's add a new action associated with the gun to set the layer to be the same as the physics player. Just copy-paste the previous event and replace player with gun. If we quickly check, we can now see that the player and its weapon back. Let's now add some effects to make it look better. The first one will be a small water splash that we will be moving with the player as it moves through the water. In the main game event sheets, look for the events where we are checking the collision between the physics player and the platforms. Right-click on it, and select Add New Event below. Add a new condition and select the physics player. In the search box, type collision, and select the action. In the object field, type Choose the water limit. For the action, we will make appear the splash, but we have not yet created it. So, let's do it now. Go to the game scene view, and right-click on the canvas, and select the option Insert New Object of Type Sprite. Click and add animation and then edit with Piskel. Use your drawing skills to draw something relatively similar to what could be some small splash caused by someone walking in the water. We are using blue and white color for the first test. Save as water splash and go back to Gdevelop main game event sheet, where we have left it. In the action, select the water splash, and in the search box type Create. Select the Create Object action, and in the X and Y position, type Physics Player X and Y. In the layer, make sure to choose the game layer. Add a new action associated with the water splash. In this case, change Z order to be one more than the physics layer Z, as we want the splash to be always in front of the player. Add a new sub-event, and in the action, choose the water splash object, and position of an object. Use Physics Player X and Y to move the position of the water splash. In the game scene view, let's adjust the water splash object in size, and let's edit some of the points to make the pivot and origin be at the center of the object. And in a second thought, we have drawn some blue water on it. But it would probably create problems with the colors of water that we could be using in other levels. So, let's delete the water and keep only the white foam. We will also need to have some variables to keep track of whatever the water splash is active or not. So let's create a variable on the object, by click on the Instance Variables button in the left pane. Name it Active, and set the initial value to 0. In the main events sheet, let's add a check to the value of the variable to avoid running the code associated with it if not necessary. So, click in the Add condition, choose the water splash object. In the search box type variable, and then select the option value of an object variable. In the variable field, choose active, and in the sign field, equals to. In the value to compare, 0. Add a new action, to set the value of active to 1. Initially, we had placed the event to move the splash as a sub-event, but it is better to move it to the event level, and add a condition where we check on the value of active to be 1. In the same way, we don't need to create every time a water splash object, we just need to show it or to hide it, when touching or not the water limit. Let's make the changes to the code. So, delete the create object action and add a show action associated with water splash. Copy the entire event and paste it below. Invert the condition where we are checking if in collision with the water limit and replace the value of active with 1. Delete all the actions, except the show action. And replace it with a hide that will make the water splash invisible. At the on beginning of the scene event, let's add also a hide water splash action. Run the game, and we are walking on the water, although we can part of the body below the water splash. Also, we are seeing the background of the water with too much definition, which removes some credibility. We can jump and the splash disappears. Go back to the scene view. Insert a new sprite object and name it water plane. Add an animation and edit it with Piskel. Select a blue color and paint the full canvas with the paint bucket. Save it as water plane and go back to Gdevelop. Size the object up, as we have done with the water limit, but in this case, adjust the size of the height too, as we need it to cover all the bottom of the water. Set the layer to game. And a Z order above the player's one. So, in our case, around 200. Adjust the water splash Z order to be 1 or 2 units above the Z layer of the water plane. At the on beginning of the scene event, let's add an action associated with the water plane, but lower down the opacity slightly, to allow for some elements behind to be seen. In our case, we are lowering it down to 125. Let's run the game. And the player falls into the water, and we can see it slightly behind the water. Adjust positions and opacity until you are happy with it. You can also play with the center and origin point of the water splash to fine-tune where to show relative to the player's feet. Now, time to make the player shoot late in the ground. It took us in including this part of the tutorial because the animation was not available in the animation pack for the character. The same happened with other animations, but we were able to use the Adobe Animate tryout to make them. The tryout period ended, and we were not able to find another tool that was able to import the animations and edit them. After some heavy research, we were able to find a rather interesting workflow that allowed us to do it. All the tools will be referenced in the description. First thing, is to decompose and extract the parts of the animation. We were able to do it with GAF Converter, which takes a flash animation and can extract the animations and their building parts. The different parts of the animation are saved into a sprite atlas in the PNG format. We can then use Shoebox to cut each of the sprites in the atlas into a separate file, which is required by animation packages like Spriter or Dragon Bones to remake the structure of the character. In this case, we use Spriter, because it can import directly all the parts located in a working directory. Once imported, you just have to reassemble the character, set it in the pose that you want, and animate it. So, we have created two rough animations, one idle down, and a fire down animations. We need to add them to our player sprite, so, edit the object and add the two new animations. We need to add a new image point to the animations. That we will be calling gunpoint and is to be placed in the tip of the wrist of the character's arm that holds the weapon. This is where we will be placing the gun in the code. Let's also adjust the position of the origin and center points as to be right on the place where the character would touch the ground. For the gun, we will use for now the same animations that we already have, but we will have probably to change the way we are currently adapting the gun animations with the player ones, as we still have a lot of glitches in the animation. To manage the down state, we need to create a new state in our state machine. So in the main game events sheet, let's scroll down to the section where the state machine is implemented. Copy one of the states and paste it. Repaste the state tag, with a new one down. We are also required to point to a new external event sheet, that we have not yet created, so let's do it now. Click in the Project Manager on the top menu, and then, click on the External Events option. Create a new external event with the name Player Down and let's associate it with the include command. Before creating the code for the state, let's do some planning. The player can shoot down from being idle, or from walking. If he is walking, then we will stop shooting, will lay down, and then shoot. So, we need to make transitions for the player moving and player idle state into the new player down. So, let's open the player moving event sheet. In the transitions group, let's copy-paste the event associated with transitioning to the jump state, and let's modify it the down state by inverting the conditions. So, if the arrow down key is pressed but the jump key is not pressed, then this means that we want to go into the down state. Let's replicate the same changes for the player idle, as move also to the down state if the button down is pressed but not the jump. In the previous tutorials, we included a check on if the player is not moving, which is not as we are in the idle. This means that the condition is not necessary and we can delete it. open the player down event sheet now. It will ask to choose a scene to be associated with, select any scene in the project. Let's go to the player idle event sheet and let's copy everything and paste it back in the player down sheet. The first thing that we need to do is to change the animation to be played. It is no longer the player idle, but rather player down idle. Then we need to add a new action to set the position of the gun to the image point named gun point on the player animation and that we have set to be around the wrist. For this, we're going to use for the X and Y position, player 1.x gun point, and the same thing for player 1.y. Let's run the game. If we press the down key, then the player goes down to the ground, but we can see that the weapon is still hanging in the air. If we shoot, as expected, the bullets are also fired from a higher spawn point. The problem is associated with the gun and how we integrated it earlier on this series of tutorials. We have two animation sets for both the player and gun that are running the same relative animations. Now that we have changed the player animation, the gun animation is not synced, and there's the problem. It is better to have the gun locked into a specific point and not through the animation. This will give us more flexibility. So, let's do it now. Go back to the game scene view, and edit the gun object. Create two new animations. Gun idle down 0 and gunfire down 0. For the idle, select only one image of the series of images available. Let's edit the points, and let's place the origin and center points in the place of the sprites where a hand should be linked to. This will allow the gun to be precisely placed at the right position when called from the down state. For the fire, let's select all the animation frames. Let's replace now the name of the gun animation in the player down state, with the names of the new animations just created. If we run now the game, the player takes the right position and animations when idling, but when firing, the animation is not correct, and the bullets are still being fired from the wrong position. Let's fix it. Above the events that we have been editing, we have a couple of collapsed events. One of them is associated with the fire button being pressed, X in our case. You can see that they are referring to the wrong fire animations names. Let's adjust them, and let's take the opportunity to delete some of the events that do not apply to the player down state. And now if we run again the game, we can shoot correctly, and the bullets are spawned from the current point. While down, let's try to fall off the platform. And we have a small problem, as the player falls with the lead down animation. The problem is located in the transition group of the player down state. The second condition is still pointing to its own state. So, let's replace it with jumping. And then let's invert the conditions as if the down key is pressed and we press the jump button, then we should go to the jumping state. And if we run again the game, we can now fall correctly, but we have another problem. If we shoot, the bullets are disappearing behind the level tile maps. This could be related to the bullets being spawned in the wrong layer, or with an incorrect Z order. Let's check in the events responsible for firing the bullets in the main game events sheet. Seems that the layer is correct. So let's add a couple of actions to set the muzzle flash and bullet trail to a higher Z order of 150. Let's run again. Now the bullets and the trails are appearing correctly. One other problem that we currently have is that our camera is too close to the player. In the original Contra, the camera is further away. So, let's implement a camera management system that will zoom into the player when not moving, and will zoom away when the player starts to move. The easiest way is to take advantage of the moving and idle states and try to make the camera zoom in and out. To perform a zoom, we have an action to zoom the camera that receives values between 0.1 and 2. To make it progressive, we need to use the lerp function that interpolates a number between two values. So, in our case, in the player moving state, when the player is moving, let's add an action with the change the camera zoom. In the zoom value, let's type the lerp function, and in the first field 1, in the second 0.5, and in the last one, time delta, or the time between frames. Let's copy the same function into the player idle state, when the player is on the floor, and permutating the values 1 and 0.5 as we want to zoom in on the player. Be careful to set the layer field to game, or the name layer that you could be using in your game. Let's run the game to see the changes. The zoom is somewhat chaotic, we have the camera zoom in and out in an unusable way. This means that the approach is not suited as we can control it. Also, while in the water, we have seen that with the camera zoomed out, there is a lot of the level that disappears. So, let's try to fix everything. The water is easy to fix, is just to increase the height of the water plane to cover all the bottom of our level. For the camera management, we need to take another approach, and to manage it at the game level with global variables to control the process of zooming in and out. So, click on the Project Manager, and then in the Game Settings. In the Global Variables section, create 3 global variables, camera zoom, to hold the current zoom. Camera zoom near, to hold the maximum zoom we can do. And camera zoom far, to hold the minimum zoom of the camera. The initial values will be 1 and 0.5. Now, in the main game events, first, let's set the initial camera zoom to the current zoom of 1. Then, let's create a new group and call it Camera Management. Add a new sub-event to the group. Leave the condition empty and in the actions, add a new action to change the zoom of the camera. In the value field, type global variable camera zoom, in the layer, our game layer. Add new event below. In the condition, check if physic player is moving. In the Actions search box type global and then select the option value of the global variable. In the variable field, select a camera zoom. In the modification sign, select subtract. And in the value, time delta. Add a new condition, where we are comparing the value of global variable camera zoom to be greater than global variable camera zoom far. Copy the event and paste it below. In the condition, replace camera zoom far with camera zoom near, and the greater than with less than. Invert the condition physics player is moving. In the actions, replace the subtract with add to. Let's run the game. And now the camera zooms in and out smoothly into the player. There are still glitches associated with changes of direction, but we will address this in another video as this one is already very long. There is another small bug that we can fix very easily, as if you move the player through the water up to the end of the level, you can see that the bullets from the turret are suffering the same problem as the player's bullet due to the Z order. Fixing it is just by setting the Z order after creating each of the bullet and bullet trails. Let's run the last time. In the next video, we will be fine-tuning the level to fix the holes in the tile map, we will be putting enemies on the platforms and in the water, and we will start planning for the final boss in the level. We hope that you have liked this video. If it has been the case, consider subscribing, giving a like, and clicking on the notification button. If you have any questions, problems, or comments, don't hesitate in putting a comment and we will answer as fast as we could. See you in the next video, game developers.